Okay, on this video, we're going to talk about test live, test dead, test live. Now, if you're on the job, you're going to have a pair of voltage rated gloves. So, just so you can see how long it takes to test gloves, I'd always do this in the morning when I was on a job, run my hand up in them, check between the webbing, okay? Blow them up, run it across my face, see if I feel any air leaks. Look, see if any scarfing is on there, see if the rubber's rolling up, if there's any cuts, punctures, so on. Pull it inside out. Do the same thing, okay? Now, I'm talking while I'm doing this. You know, you're waiting in the morning talking about what you need to do. You're doing this, it doesn't take too long. And again, how big of a hole does it take for an electron to get through? The answer is it's not much of a hole. Electrons are little bitty fellers. Little bitty fellers. So, then I'm gonna run my hand in the leathers, make sure there's nothing in the webbing, and pull it apart. Make sure none of the stitching coming apart. I already did these, but I'm going to do it again because that's where a hole will form a lot of the time in a glove. Put this back on. And NFPA 70E says you'll do this every day at the beginning of your shift and any other time that it may be necessary, okay? So, just when you get on the job, get into a habit, looking at it, pulling the fingers apart. A lot of gloves are two colors, one color on the inside, one color on the outside. So if they're yellow on the inside, black on the outside, when you pull that, it's real easy to see a hole. So then, pull it out, slap it on your leg, blow it up. Look in the web, look for any deformation on the rubber. If you've ever fixed a bicycle tire and you know how whenever the patch doesn't go on well, it sort of rolls up and comes off in layers, sometimes a glove will do that. If a glove does that, then, that one doesn't want to come in, there we go. If the glove doesn't want to come out, or if you have that rolling up on the rubber, it's a bad glove. So you go to the storeroom, or you order another one, or you go by rec sale. It's being an ornery little thing. I don't know why. They must be kinked up in there. They normally pop right out. There we go. Now, I'm going to look between the webbing here. Look on both sides. I'm gonna stick my hand up in it, make sure there's no sharp wire that's going through here that I'm not seeing. You know, when you do that, you're gonna... Now, just that quick, and I was talking, I've checked my gloves and I'm good for the day. Or I'm good until I think I might have done something to compromise it. If I'm out there and I'm testing or something and I happen to reach and I feel something poke through here, I'm gonna back on and check my glove, because if it's bad, that's the time you catch it, not whenever you come into contact with a live circuit. Now, we're gonna talk about using our meter and testing a circuit for the absence of electricity. There's two things we look for when we're testing a circuit: the presence of voltage or the absence of voltage. If we're getting ready to work on a circuit, if we're getting ready to change a motor, if we're getting ready to change out a starter, if we're getting ready to go inside this panel and change out a part, we have to check for the absence of voltage in order to lock it out as per OSHA and NFPA 70E. So the first thing we do, we take our meter, we take our leads off, and we're going to slightly tug right here. This is a strain relief, and they have a tendency to break there. So if it springs out like a bungee cord, that wire is broken, and we need a new set of meter leads. I'm going to run my hands along these leads and see if I feel a cut or anything. I'm going to watch it at the same time. When I get to the other end, I'm going to tug here, same way, and see if I feel it like a bungee cord. Then I know that lead's broken. I don't know how many I've had break over the years in my life, but there's been plenty. And if they're a broken lead, and all we do is just go right in there and put we're looking for 0 volts, and we put our meter on there and see 0 volts. What if it's hot? We got a bad lead. So there's a way we go about checking. It's called test live, test dead, test live. So I'm gonna put my leads back on here. And what I'm showing you is the right way to go about testing for the absence of voltage. Now, if we're testing for the absence, that means it might be hot. We're going to prove that it's dead. So, we're going to have our sleeves down inside the cuffs. I know mine's rolled up a little bit, but I'm short armed, so my sleeves are still long enough to be up inside the cuffs of my glove, okay? And we got our eyeglasses on, safety glasses. We're going to open up our door. This is where the power is fed in. We want to make sure this panel's dead, okay? So, even though we've checked our meter leads, we want to prove those meter leads are good. So we're going to put it on voltage. So this is test live, test dead, test live. So we need to put this on a known voltage source. 70E doesn't tell us what is a known voltage source. They leave that up to us. But what's the easiest one to find? 120 volt outlet, right? So over here is a 120 volt outlet. I'm going to plug it in here. I read 122 volts. Now, coming to a quiz midterm final near you. We call that a 120 volt receptacle. 120 volts is the nominal voltage of that receptacle. Nominal means name. It's the name of that receptacle. But the other voltage that I talk about is the measured voltage. If you notice, we read 122 point something. That's actually the voltage at the outlet. It's 120 volt nominal, or the name of that circuit is 120 volt circuit. But the measured voltage is 122 volts. Most of the time, our measured voltage should be higher than the nominal voltage of that circuit, or the name of that circuit. On a 480 volt circuit, which is what a lot of motors run on, it'll be around 495, 498 volts for a 480 volt circuit. 480 is a nominal voltage, or the name of the circuit. 496 would be the measured voltage on the 480 volt nominal circuit. So, nominal means name, 120 volt outlet. Measured voltage, 122 volts here. Yours at home probably around 126, 128 volts. Check it and see. So now that we checked that, we have proven, test live, we know it's hot, we got a hot voltage. And if we don't get a hot voltage there, we're going to check somewhere else, and then we're going to start looking at our meter, right? So, we proved our meter's good. Here, this is 208 three-phase nominal. So there's 6 tests to check. We have phase A to phase B, phase A to phase C, phase B to phase C, and then we pick anything shiny in here that's ground. Then we go phase A to ground, meter drop. phase A to ground, B to ground, C to ground, okay? So I'm gonna do it again and watch my meter. 6 tests for a 3-phase circuit. Phase A to phase B, 0. Now, when I say 0, I got 0.8 volts. That's noise. These things are so sensitive. They're gonna pick up a few tenths of a volt noise, but we're looking for meaningful voltage. Now, if I see 80 volts, I'm probably gonna back up a little bit and wonder what I'm seeing. Could still be noise, could still be stray voltage, but we wanna make darn sure before we pull our gloves off and work on the circuit. So, phase A to phase B, 0.8 volts. Phase B to phase C, 1.05 volts. Phase B to phase C, 0.6 volts. Okay, now, I'm going to put this lead here. There's a ground, well, down here is shining. This whole cabinet has to be grounded and bonded. So find something shiny in here. Right down here is a ground terminal. Up here is a ground terminal. Here is shiny metal, so I know it's ground. So I'm going to go ground to A, 0.2 volts. Ground to B, 0.8 volts. Ground to C, oops. Ground to C, 1.4 volts. Still 0 for all practical purposes. Now we got the test live to prove our meter, then the test dead, 6 tests up here. Now the last part of this, and this is dictated by OSHA 70E, go back and test live again. $122 volts. Now what's the odds of us having a bad set of meter leads or a bad meter, and that being good down there, bad for 6 tests, and good on the last test? Pretty remote. So right now, having tested all this, okay, and I know hands are sweating a little bit. I know it's locked out here, but having tested this, I pulled my gloves off. I can reach up here and touch it now because I used the right procedure to prove it was dead. I don't have to worry about it. Once you prove it's dead and lock it out, okay, it's locked out, then your safety gear, except for your glasses, go away, okay? So, test live, test dead, test live. We'll be doing this in the classroom. You have to do it on the job. Don't ever, 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 ever cut it short, okay? It has saved me a number of times by going through this procedure throughout my career. It has saved me from being shocked very badly or possibly even killed. So, email me any questions or bring them to lab whenever we start lab. Take care.